Have you ever really stopped to think about the road under your wheels? I mean, it just seems so simple, a plain old strip of blacktop. But that surface is actually a battlefield, and it's constantly at war with crushing weight and extreme weather. Today, we're going to peel back the pavement and show you the incredible science that goes into engineering the perfect road for your daily drive. So, let's start with the big question. What does a road actually need to do to survive? To really get that, we have to start small. I'm talking right down to the molecular level. All right, first up, the secret life of asphalts. You probably think of it as just tar and rocks, right? But oh, it's so much more complex than that. So, when you look at asphalt concrete, it turns out about 95% of it is just aggregates. That's a fancy word for crushed rocks and sand. But the real magic, the thing that makes it all work, is in that tiny little 5%. That last 5% is a substance called bitumen. And you can just think of it as a super strong, waterproof, black sticky glue. Its entire job is to hold those millions of tiny rocks together and turn them into a solid, smooth road. It's literally the binder that makes it all happen. But here's the problem. This amazing glue has a huge weakness. When it gets really hot, it starts to get soft and gooey. And when it gets freezing cold, it gets brittle and just cracks. And you have to understand, if the glue fails, the entire road fails. So how in the world do you fix a problem like that? Well, this is where the really clever science comes in. Engineers figured out a way to basically give this glue superpowers. They found a way to supercharge it. They do this with something called polymer modification. And it's pretty much what it sounds like. They mix in these special long-chain molecules, polymers, right into the bitumen. You know, it's kind of like adding spandex to a pair of jeans. All of a sudden, the material is way more flexible, a lot more resilient, and just tougher all around. And the difference is, honestly, it's dramatic. Take a look at this chart. That vertical axis shows how strong the glue is. See that light blue line, the one labeled BB2? That's your standard off-the-shelf asphalt glue. As the temperature at the bottom goes up, just watch how its strength absolutely nosedives. That's your road literally turning to mush on a hot summer day. But now, look at the dark blue line, MV2E2. That's our glue with those polymer superpowers. At the exact same high temperatures where the regular stuff just gave up, this modified glue is holding strong. It's fighting the heat. That right there is the power of polymer modification, and it's the difference between a smooth ride and a road full of ruts and bumps. So what does all this high-tech science actually mean for our roads? Well, it means the pavement is way better at resisting those ugly ruts from heavy trucks in the summer. It means it doesn't freak out during big temperature swings. And it can fight off cracking from all that repeated traffic, day in and day out. Bottom line, it makes a much stronger road that lasts longer and saves a ton of money over its lifetime. Okay, so tweaking the molecules is a huge step, but that's only half the battle. Now we've got to zoom out from the lab and face the road's biggest, most relentless enemy, the weather. I want you to just look at this number for a second. 8.5%. Seems kind of random, doesn't it? But what it stands for is pretty incredible. According to a huge Federal Highway Administration study, that's the percentage of total road damage in some places caused by the environment alone. We're talking with no heavy trucks, no traffic at all. Just the sun, the rain, and the changing temperatures are enough to cause major damage. The weather is a seriously destructive force. And it really attacks in two main ways. In the summer, all that heat softens the bitumen glue, right? So the weight of cars and trucks literally squishes the road into ruts and grooves. Then in the winter, the freezing cold makes that same pavement super brittle. It shrinks, it gets stressed, and boom, it cracks. It's basically under attack all year long. So it's pretty obvious that the asphalt recipe you'd use for a road in scorching hot Arizona is not going to work for a road in freezing cold Alaska. This means you need a whole other level of planning. You have to engineer a specific road for every single climate. To pull this off, engineers came up with a really smart system called the Performance Graded Binder System, or PG for short. You can basically think of it as a weather rating for the asphalt glue. So if you see a grade like PG 64 or 22, it just means that glue is designed to work perfectly in a place where the hottest pavement temperature hits 64 Celsius and the coldest gets down to minus 22 Celsius. And this is how they put it into practice. They use these incredibly detailed climate maps, like this one for Texas. Each color on this map tells an engineer exactly which starting PG grade they need for a road in that specific county. It means an engineer in dry West Texas is going to use a totally different glue than one building a road in humid Houston. And getting this right is everything. If you pick the wrong one, you've just wasted millions of dollars on a road that's doomed to fail early. But they don't even stop there. Picking the grade from the map is just step one. Then they adjust it. Is this road going to be a crazy busy highway with tons of heavy trucks? They'll bump up the grade to something tougher. Is it for an intersection where cars are always stopping and starting, putting more stress on the pavement? They'll bump the grade up again. It's this super precise multi-step process to get it just right. Okay, so let's bring all of this home. Let's put all of the pieces together and see how this incredible science comes together to engineer your daily drive. You see, it's this whole journey. It starts in a lab with scientists giving molecules superpowers. Then it moves to a planner's desk with giant maps and data that tell them the perfect weather rating. And then finally, construction crews are out on the ground laying a pavement that's been precisely engineered for that exact spot on Earth. And the final result, the thing that's right under your car's wheels, is a surface designed from the molecule up to survive everything its local environment can possibly throw. So, the next time you're out driving, just take a look down at the blacktop. Are you going to see just a simple road, or are you going to see what it really is? A hidden, complex, and totally brilliant feat of engineering, designed molecule by molecule to make your journey safe and smooth.